We are going to walk through two examples where we are going to estimate the value of the integral that we're given using the comparison property. I've written the comparison property over here in this green box. Little m is the absolute minimum value of f of x on the interval, and then capital M is the maximum value of f of x on our interval. Let's begin by writing down that f of x is equal to x cubed, and our interval that we're integrating over is from 0 to 1. The first thing that we want to do is find the critical values of f of x. So we're going to take the derivative. F prime of x is equal to 3x squared. We set that equal to 0, and we get that x is equal to 0. That's a critical point, and it's also an endpoint. Our second step is to compare the value of our function at our endpoints and at our critical points. So we're going to compare f at 0, which is 0, to f at 1, which is 1 cubed, which is just 1. The smallest value is going to be little m, so 0 is little m, and then the biggest value is capital M. Now we can estimate the value of our integral using the comparison property. Little m is 0, so we have 0. We'll go ahead and put b minus a, but we really don't need to because we have a 0 there. That is less than or equal to the integral from 0 to 1, x cubed dx, less than or equal to capital M, which is 1, times b minus a, which is 1 minus 0. So we can say that 0 is less than or equal to our integral from 0 to 1, x cubed dx is less than or equal to 1. Our answer is then that this integral is greater than or equal to 0, but less than or equal to 1. Let's look at our second example. We are going to estimate the value of the integral from 0 to 2 of x times e to the minus x. We'll start by writing down that our function, f of x, is equal to x e to the minus x, and our interval is from 0 to 2. Our first step is to find the critical values, so we're going to take our derivative, f prime of x is equal to, we're going to need to use the product rule, so we have our first function, x, times the derivative of our second, which is minus e to the minus x, plus our second function, e to the minus x, times the derivative of x, which is 1. We set this equal to 0. Notice that we have an e to the minus x common to both terms. So we'll pull that out, and then we have a 1 minus x is equal to 0. An exponential function is never equal to 0. So all we're going to do is set 1 minus x equal to 0. And this gives us that x is equal to 1. And that's our critical value. Our second step is to compare the value of our function at our endpoints and at this critical value, x is equal to 1. So we'll start with f at 0. This is 0 times e to the minus 0, so that's just 0. And then f at 1 is 1 times e to the minus 1. This is 1 over e. And this is approximately 0.37. And then f at 2 is 2 times e to the minus 2. And this is 2 over e squared, which is approximately 0.27. Now we want to compare all three of these values. Our smallest value is this value right here. So we're going to let this be equal to little m. And then our largest value is 1 over e. So this is equal to capital M. In our third step, we're going to substitute these values into the comparison property. Let's go ahead and write down our formula. We have little m times b minus a is less than or equal to the integral from 0 to 2, xe to the minus x dx, and this is less than or equal to capital M times b minus a. Little m is equal to 0, so we have 0 on the left-hand side, less than or equal to the integral from 0 to 2, xe to the minus x dx, less than or equal to capital M, which is 1 over e, I'm putting in the exact value there, times b minus a, which is 2 minus 0. So we can write down that our integral is between 0 and 2 divided by e. And that just gives us a nice estimate of our integral.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.